Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and welcome back in our lesson today. And in this video, we are going to talk a new topic actually, but it is still related to uh, electrical things. Yeah. Okay. So today, yeah, we are going to learn about the oh wait direct direct current. Yeah. Okay. So in this topic, yeah, before I tell you about what direct current is, yeah, I want to tell you that um, in previous lesson, yeah, we were talking about something called um, static electric, yeah. In this static electric, uh, we um, talk about uh, Coulomb law, yeah, which is the formula is F, yeah. We are talking about the force of charge, yeah. K pq times small q divided by r square, yeah. And so we talk about the electric field, yeah. E, yeah, K pqn divided by r square, yeah. Now, in this static electric, yeah, we do not we do not think about uh, moving charge, yeah. It means that the only thing we learn is all about, let's say we have positive charge or negative charge, then we do not learn about what if when this charge move, yeah, from one point to another point, yeah. In this topic today, yeah, we are going to learn about something called with, so uh, doesn't move, yeah. The electric charge is doesn't move, yeah. And also for this one, it doesn't move, yeah. Now, now um, what we are going to learn is about dynamic electric, yeah. So in dynamic electric, yeah, we are learning about how charge, yeah, moves from one point to other points, yeah, and what effect that produced by this movement, yeah. Yeah, so let's say we have point A and point B, yeah. Then this is the charge, yeah. This is the charge of you can mean mostly, yeah, the moving charge is the negative, yeah, because as we mentioned, yeah, before, yeah, on the previous lessons, that we know that the active charge is negative charge, yeah. Yeah, so electron is very active, so it can move, yeah, from one point to other point, yeah. So this is the electron, yeah. Sometimes people use E symbol, yeah, to represent um, the electron, yeah. The electron is negative charge, yeah. The negative sign have I mean electron has a negative sign, yeah, of the charge, yeah. So because the electron move, yeah, from A to B, then we call it with dynamic electric, yeah. And in this lesson, yeah, we are going to learn, yeah, when the electron, yeah, moves from one point to other point, yeah, in a certain media, yeah. Let's say we have electric wire, yeah. So let's say this is the electric wire, yeah, or in bahasa Indonesia we call it with kabel listrik, yeah. And inside the electric wire, yeah, there is something called with electric current, yeah. So there is electric current, yeah. Nah, the the word the word current here, yeah, means there is something move, yeah, because that's why we call it with current, yeah. Current in bahasa Indonesia means called aliran, yeah. So electric current means aliran listrik, ya. So something must be mengalir, ya. Sesuatu akan mengalir, ya, from one point to other point, ya. Let's say this is the A and this is the B, and in this um, in this wire, yeah, in this cable, yeah, there will be a lot there will be a lot of charge, yeah, moves from, let's say, from point A to point B, yeah. So this is um, electron, and so this is the electron and it's the electron, yeah. And something that makes electron, yeah, moves from point A to point B, because there is a difference, yeah, between um, difference of voltage, yeah, between A and B, yeah. So in this point A we have voltage of A, yeah, voltage A, yeah, and then in point B we have voltage B, yeah. Or electric, or sometimes voltage can be also written, yeah, as electric uh, potential, yeah. A electric potential of B, yeah. And because the V of A, yeah, is bigger, yeah, or is greater compared to V of B, yeah, then the current, yeah, the electron will flow, yeah, will move from point A to point B, yeah, from point A to point B, yeah. And if the the electric potential of B, yeah, is higher than A, then that electron will move from B to A, yeah. But in this case, because the voltage of A, yeah, is greater than B, then the electron moves from A to B, yeah. Okay. Yeah, so this is the main concept, yeah, of how electron can be moved, yeah, from one point to other point. Okay, so if we take a look on this, yeah, if take a look on this um, paper, yeah, there will be a lot of formula here, yeah, and actually you can just um, read it by yourself, yeah, because it will take time, yeah. And actually I have uh, explained, yeah, all of this formula, yeah, all of this formula, yeah, from this one, then it will derive into this one, yeah. And we got a lot of integration, and also we have a lot of differentiation, yeah. And actually this explanation, yeah, has been uh, has been explained in lesson ya in bahasa Indonesia ya. So I have put another video ya. I am telling about this formula ya. I mean the process of getting the formula ya in bahasa Indonesia. So if you want to know more about um, how this formula can be produced, so I suggest you um, to watch my video about this one in Bahasa Indonesia. But in this English version, I just point out some important formula, and we can just simply use it in our calculation, Okay, so so I think we don't have any important equations here, important formula that you have to memorize, in this page one. So we can go to second page. Okay, so um, the first important formula is this one, so I will mark this one, so this one is important formula. And how this how this formula can be like this. Actually you can just follow all the formula here, so from this one, from this one, then you got a lot of things here, and finally you will come into this formula. I mean you will arrive for this formula. And in this formula, the E is electric field, and then the V is potential, electric potential, I mean. And D is distance. Okay, so what can we know from this one? So let's say I have electric wire here. So this is the electric wire, and this is the electron. So E, the electron moves from point A into point B, and distance between A and B is D, and the potential, I mean, this one, the difference, uh, potential uh, difference, of A and B, is VAB, So in bahasa Indonesia, I will translate it, Jadi beda potensial atau beda tegangan antara titik A dan B itu adalah VAB, the difference, the potential difference, So this one, the potential. The potential difference between point A and B is VAB, or sometimes just mention with V, Okay, so because there is potential difference between A and B, then the electron will move from A to B in the distance of D, and the electron will produce electric field, the movement of E from A to B will will produce electric field. Wait a minute. Yeah, I'm sorry, there is a technical problem. Okay, so produce electric field E, yeah, and the amount, I mean the value of E will be here, yeah. So the value of E, yeah, will be E equals to electric potential, yeah, divided by D, yeah. Okay. Okay, so that's for the first important formula. And then, uh, okay, so another important formula is this one, yeah. Okay, um, so I will translate it for you. Okay, so let's say there is a conductor, yeah. So conductor is something that conduct the electric current, yeah. And meanwhile, the inductor is something that inhibit, yeah, the current of electric, yeah. Okay, so the conductor is simply like electric wire, yeah. So cable, yeah, or electric wire is um, another kind. I mean, is an example of conductor, yeah. So conductor mean uh, material, yeah, material that conduct electric electricity, yeah. And the other, I mean, the opposite things of conductor mean inductor, yeah. No, no, no. Conductor is just conductor, yeah. Okay. Uh, let's say we have conductor, yeah, and the length, yeah, of the conductor is L, yeah. So L is length of conductor, yeah. Okay, so I'm sorry. Um, the opposite things of conductor is insulator, yeah. Yeah, I'm sorry. It is not inductor but insulator, yeah. Insulator, yeah. So it will inhibit the electric current, yeah. Yeah, okay, so let's continue, yeah. The L, yeah, the L is length of conductor. So yeah, so this one is the conductor, yeah, and the length is L, yeah. And in the edge of in this in every edge, yeah, of the conductor has uh difference potential of V, yeah. Yeah, so big V, yeah, is uh, potential difference, yeah. Yeah, potential difference. And then um, small n, yeah, small n is amount, yeah, is amount of electron, yeah, moves, yeah, electrons move in uh, in the conductor, yeah. And then E, yeah, is um, value of electric charge, yeah, of single electron, yeah. And then V, yeah, V is small v, yeah, because we have two v's here. The first one is small v, the big V, and then the small v, yeah, is for um, velocity, yeah, velocity of electron. Nah, and then I is um, intensity of electric current, yeah. E, yeah, intensity, how intensity, yeah, intensity of electric current, yeah. Nah, and A, yeah, and A is the area, yeah, is the area of conductor, yeah, area of, yeah, cross area, yeah, not only area, but it is cross area. Nah, all of this, yeah, has uh, relationship, yeah, of this, yeah. So this one is I, yeah, I is the intensity of electric current, yeah, and the unit of I is ampere, yeah, yeah, is ampere, yeah. Hmm. So A is um, I is ampere, yeah, and then N, yeah, is amount of electron is moved in the conductor. So because in this conductor, yeah, we believe that it is not only one electron, yeah, it will be millions of electron, yeah. So N is the total amount of electron, yeah, moves, yeah, in the electric in the conductor, yeah. And then E, yeah, is a value of electric charge, yeah, value of electric charge, yeah, of single electron, yeah. And then V, yeah, V is velocity of electron, yeah, because the electron will move from one point to other point in certain velocity, yeah. So V will represent, yeah, the velocity of the electron, yeah, that moves from point one to other point, yeah. And then A, yeah, A is cross area, yeah, cross section area of conductor, yeah. So let's say in this apa in this part, yeah, it has surface area of A, yeah. So let's say this is electric electric wire, yeah. Yeah, then um, this one, yeah, is A, yeah, the area, yeah, A for area, yeah, cross section area. Cross section area. Okay, that's for this one, yeah. And then other important things is this one, yeah. Oh no, this one, yeah. Yeah. So J, yeah, J is density of electric intensity, yeah. Yeah, so the value of J can be obtained, yeah, from value of I, yeah, divided by A, yeah. So J equals to I per A, yeah. And the unit of this one is A per meter square, yeah. Okay, and for this one, yeah, it is A, yeah, for ampere. This one is meter square. Okay, now this one, yeah, so this is the electricity density, yeah, density of electricity, yeah, or density of electric intensity, yeah, equals to mu, yeah. So in this case, mu is coefficient of mobility, yeah. So mobility coefficient, yeah. The N is total amount of electron, yeah, in a conductor, and then the E is single value of electric charge of electron, yeah, and then E, yeah, E is electric field, yeah. Okay. Now next to ah, and then the other important formula is this one, yeah, yeah. So what is this formula, yeah? So I will rewrite, yeah. Okay, so I think this one is not clear enough, so I will change, yeah. R uh, P I mean rho, yeah, L per A, yeah. So 1 per R, 1 per R, yeah, equals to A divided by rho L, yeah, or yeah, R equals to rho L divided by A, yeah. Nah, R, yeah, called resist resistance of conductor, yeah, and um, the unit is ohm, yeah, or this one omega, yeah, ohm, yeah, and then rho is coefficient of resistivity, yeah, and it depends on the material, yeah, because every material has their own value of rho, yeah, depends on material. And for the unit, I'm sorry, I forgot, yeah, I will, okay, I will find first, yeah, I will check it first, wait a minute. Okay, I think we are going to find it later, yeah. And then the L, yeah, L is length of conductor, which unit is m, yeah, for meter, and A, yeah, is the cross sectional area, cross sectional area of conductor, yeah, yeah, which is m square, yeah. Okay, now what is the unit of coefficient of resistivity, yeah? Okay, so we are going to find from this one. So R rho L divided by A, yeah. So the unit of R is omega. Wait a minute. Okay, sorry, there is a technical problem. Okay, let's continue. Rho is something that we are going to find, yeah, and then L is m and then the A is m square. Yeah, so yeah, so rho the rho it will be equal to omega times m square divided by m. Yeah, okay, so the unit of r is rho meter. Yeah, okay, so omega meter, so this is the unit of rho. Yeah, okay, so if we have oh, I'm sorry. Okay, so if we have conductor here, yeah, and then the length, yeah, of this conductor is L, yeah, and then it has cross-sectional area of A, yeah, then then the value of R, yeah, will be uh, rho, yeah, which is depends on the material itself, times by L, yeah, L is length of the conductor, yeah, divided by cross-sectional area. Okay, so this formula, yeah, can be used to find the resistivity of certain material, yeah, or certain conductor. Okay, now we go back to another important formula. The other one is this one, yeah, which is called with Ohm law, yeah. V equals to R times I, yeah. So V is potential, yeah. So V is potential, yeah, electric potential. The R is this one, yeah, resistivity, yeah, and then I is electric current, yeah, in ampere, yeah. V equals to Ri, yeah. And then other important formula is this one, yeah. So this is the power, yeah, the power of electricity, yeah. So P, yeah, is power, yeah, in this case the power of electricity, yeah, watt, yeah, and then V is potential, which is volt, yeah, and I is intensity, yeah, which is A, yeah, for ampere, yeah. So this one is also important, yeah. And then another important formula is this one, yeah. Okay, so power equals to volt square, yeah, divided by R, and also equals to I square, yeah, times with the resistivity, yeah, or R, yeah. Okay, I think that's all, yeah. Our explanation about the dynamic electricity, and in other meeting we are going to learn about the resistor system, yeah. But I think it's enough for today, yeah, because we have a lot of things to be memorized, yeah, and you can just focus on the box, yeah. I mean, you can just focus on the formula in the box that I have made, yeah. So you can just memorize them all, yeah. Okay, so thank you for your attention today and have a nice day. Wassalamualaikum warahmatullahi wabarakatuh.